Hi, Randy again, and welcome to episode 7, the series finale of What is Document Automation. If you've been watching, the purpose of this series is to help you understand the concept of document automation, or DA, essentially the process of transferring the traditional administrative tasks of figuring out what a document is and capturing some business information off of it from the human and into the machine. Last time I talked about validation, the act of applying some sort of action on extracted fields to verify whether the values are acceptable and correct, or whether a human has to get involved. This episode expands on that concept. I mentioned the idea of pattern matching, the concept of comparing extracted data to a pattern. That sort of a match, while making sure that much of what can go wrong during extraction didn't happen, can't validate whether the extracted value makes sense in the context of the larger business transaction. Data matching can add that. Comparing the extracted value against a known set of values from a source like a business transaction database raises the possibility of a correct read. If other extracted field values also match to the data source, then the possibility increases even further. Sometimes exact data matches are not possible. Extracting a lengthy field like a name or an item description raises the possibility of multiple errors occurring in a single value. In that case, techniques like fuzzy matching can help. Fuzzy matching algorithms compare two values and deliver a probability that they match based on several different techniques. Some of those techniques work well for text, while others work well for numbers. Speaking of probability, I've mentioned before that DA is a probabilistic enterprise. Software developers are used to deterministic situations where, given an algorithm or equation, and a known set of inputs, there is one and only one result. That's just not the case in DA. In fact, processing the same scan document twice may not deliver the same result. In DA, classification delivers a probability, extraction delivers a whole bunch of probabilities, sometimes down to the character level, fuzzy matching delivers a probability, and on and on. Systems have to organize and consolidate all those values into a final confidence value you can use and trust. And there's no single answer for the confidence value threshold that delivers a usable result. Measurement and tuning always decide the optimal value. Another factor is that most business transactions will accept some level of error. They have to, since humans make errors all the time. So the acceptable error rate can be another determining factor. In any probabilistic process, there's 4 possible results. First is a true positive, where the machine got it right and returned a high confidence. A true negative is where the result is wrong and the machine returned a low confidence or some other indication. A false negative is where the machine got it right, but returned a low confidence. And a false positive, the situation you always want to avoid. And that's when the result is wrong and the confidence level or other indicators are high. Reviewing measurements and setting the confidence thresholds appropriately throughout the process should minimize the level of false negatives and ensure that the dreaded false positive just doesn't happen. By its very nature, DA development is an iterative process, and your project may require a number of improvement cycles before it delivers the results you expect. So that's DA in a nutshell: classification, extraction, and validation. It truly is possible to move much of the work converting unstructured documents into useful, correct, structured data and relieve staff from the mind-numbing data entry tasks. However, it's much, much more than just OCR. I hope this series was helpful. We had a lot of fun putting it together, and Thanks for watching.